Hello Diksha Didi, good afternoon.
Hello, good afternoon.
Yeah, so did you do the Fibonacci recursion code?
No, I'm sorry, I was not on phone yesterday evening.
Can you repeat? I could not hear you.
I'm sorry, I could not do it.
It's all right. It's all right. We can do it today in this class only. It was a pretty difficult task in recursion, so uh, it will be clear when we do it right now. And also
Okay, thank
the
you.
yeah, so there's also a concept in functions that we're gonna see, that is passing arrays, right? It's related to passing arrays, and we're gonna see the behavior that is different when passing arrays, right? So let me just share the screen, and first we'll see the Fibonacci code, and then we can see the arrays code. All right, so the Fibonacci code is over here in C++. So as you can see, the Fibonacci series, 10 digits of the Fibonacci series are printed over here. So that, how is that happening? Here we have a recursive function Fibo, and here we have our loop in which we are looping 10 times because we want to show 10 digits: 1 2 3 4 5 6 7 8 9 10. All right, so we are looping 10 times to show 10 digits, and then what we are doing, we are saying see out Fibo I and L. So we'll take out the Fibonacci number for our current index. Like if I say Fibo 0, it will give us the first one number. If I say Fibo 1, it will give us the second number. If I say Fibo 2, it will give us the third. If I say Fibo 3, it will give us the fourth. So let's see what the Fibo function is actually doing. When 0 is passed to it, we know the first number is always 0. So we say if x is less than equals to 1. If it is 0 or 1, then return x. So if it is 0, then also return 0. If it is 1, then give 1. So Fibo 0 is 0 and Fibo 1 is 1. Now when it reaches to Fibo 2, when we call Fibo 2, then your 2 is passed, it checks over in the if statement, it goes in the else, then it returns Fibo x minus 1, that is 2 minus 1, that is 1, Fibo 1 plus Fibo 0, right? So Fibo 1, as we saw over here, was 1, and Fibo 0 was 0. So that's why it's giving us Fibo 1, 1 plus Fibo 0, that is 1, right? Because 1 plus 0 is 1, right? Next we have so Fibo 2 is also 1 now. So what, this is a different type of recursion. We know Fibo, to make it clear, we are saying we know that Fibo 0 is 0. We know that Fibo 1 1 is 1. And now finally we also know that Fibo 2 is 1, right? As we are doing Fibo 1 plus Fibo 0, that is equals to 1. 1 plus 0, that is equals to 1. Now we are on to Fibo 3. What Fibo 3 will do, it will do x minus 1, Fibo 2 plus Fibo 1, right? So we know Fibo 2 is 1 and Fibo 1 is also 1. So Fibo 3 will be 2. And this is, we are using our common sense over here. If we just see it recursively, then also we'll find that what we are getting is correct. So when we say Fibo like 3, so Fibo 2 plus Fibo 1, it, when we call Fibo 1, it returns us 1 because less than equals to 1, it returns us 1. And when we call Fibo 2, it goes in here, right? It checks and no, so it returns us in Fibo 2, it is returning us Fibo 1 plus Fibo 0, that is 1, right? So so basically over here recursively we are taking out the Fibonacci series. If I say Fibo 4, that is Fibo 3 plus Fibo 2. So Fibo 3 plus Fibo 2, that is Fibo 3 is 2 and Fibo 2 is 1, so that is equals to 3. Next we have Fibo 5, right? So Fibo 5 over here is Fibo 4 plus Fibo 3, that is 3 plus 2, that is 5. Next we have Fibo 6, right? That is equals to Fibo 5 plus Fibo 4, that is equals to 8. Then we have Fibo 7, right? That is equals to Fibo 6 plus Fibo 5. So 8 plus 5, 13. Then we have Fibo 8. Fibo 8 is 13 plus 8, 21, because Fibo 7 plus Fibo 6. So then we'll get 21. And finally, Fibo 9. So Fibo 9 is Fibo 8 plus Fibo 7, that is 21 plus 13, that is 34. So this is how through recursion we are printing the Fibonacci series. Is it clear?
Yeah, it's clear. Thank you.
It's all right. It was a pretty difficult task, so it's all right. Now we have our arrays, passing arrays, right? So what's different when passing arrays? So over here, when we are passing arrays to my function, we are receiving an array over here, and what we are doing, we are saying my array 0 is equals to 2. That's all that we are doing. Now what we check our array zeros outside, right? So the zeroth element outside was 1. Now after passing the array, inside we are saying 2. My array 0 is equals to 2, right? But now when we check out the outside array 0th element, we get 2. So basically from inside we are changing the outside array. How is that happening? Whenever arrays are passed, they are passed by reference. So whenever you pass an array, they are passed by reference by default. So when it receives an array, whenever this array that is received in the function is changed, then the outside array will also change. Is it
Okay.
So this is passing by reference, when you are passing an array by reference. You're not actually passing by reference. The behavior of passing arrays is that they pass by reference, so they automatically pass by reference. So whenever you change the array inside, it will also change outside. So
Got it.
if you want it not to change it outside, then what you can do, you can create a similar like array, one more instance of the array, and pass the array instance that any one of the array instances, so the other instance won't change. So then you will have one instance that will have not changed. So you could have created like array 1, right? That is completely this, right? And when you pass array would have changed, and array 1 wouldn't have changed. So
Okay.
they are by default passed by reference. So this was about arrays and the Fibonacci recursion. Now we'll move on to constructors in classes, right? So our new concept that we haven't done till yet. So this arrays, one more thing to mention, the arrays behavior that is happening over here, passing by reference, that happens in most languages. It also happens in Python and common languages like JavaScript also, right? So the same behavior happens in Python also.
Okay.
So now constructors. A constructor in C++ is a special method, right? So it's a special method that is automatically called when an object of a class is created. Now should I delete this code, the arrays code?
Yeah, sure.
All right. So let's just create our class. Let's just create a class, my class, and over here as you can see, we are creating a constructor method. This is called the constructor method, and this method has the same name as our class name, right? So our class is also named my class, and our constructor method is also should also be named the same name as the class name, right? So if our class is named car, we have to name our constructor method car, right? And note that there's no return type given over here. We are not saying void, or we are not saying like int or something, right? There's no return type over here, right? So the constructor has the same name as the class. It is always public, right? So it is always public, right? And it does not have any return value. It will have no return value. So now constructor parameters. Constructors can also take parameters just like regular functions, which can be useful for setting initial values for attributes. Now, what is the special method? Constructor is called automatically when you create a class object. So if I say my class x, right? So when I create this object, the constructor method will automatically be called. Now when it is automatically called, we are just printing hello world. So this will automatically, when we create an object, show hello world. Is it clear?
Yes, because
Alright, so next we can also pass parameters to our constructor just like any other regular function. So we can say int x, for example, and how to pass parameters we are gonna see over here. So over here car, alright, so when you're creating the object, you just have to give brackets with the object name and then give it the parameter value like 10, right? So this is the syntax for passing parameters to the constructor when creating the object. Then after the name of your object, give the parenthesis and pass in the parameters that the constructor method requires. So this is how you will pass in parameters. Is it clear?
yeah, it's clear.
Alright. So constructors can also take parameters just like regular functions, which can be useful for setting initial values for attributes. The following class have brand, model, and year attributes, and a constructor with different parameters. So a constructor with different parameters. Inside the constructor, we set the attributes equal to the constructor parameters, like brand is equals to X, model equals to Y, and year equals to Z. Right? So when we call the constructor by creating an object of the class, we pass parameters to the constructor. So when creating the class object, we pass parameters to the class constructor, right? Which will to the object constructor. We pass parameters to the constructor, right? So as by mistake said class constructor, it's the constructor, right? So constructor of your class. So we pass parameters directly when creating the object. We pass parameters to the constructor, which will set the values of the corresponding attributes to the same. Which will set the value of the corresponding attributes the same. So we say we have the car class with brand, model, and year. Then we are saying we are creating a constructor with which will take in x, y, and z. X and y are strings, and z is an integer. And you're saying brand equals to x, model equals to y, and year is equals to z. So now when we pass BMW X5 and 1999 to the constructor, it will set brand to BMW, model to X5, and year to 1999. And similarly, when in creating object 2, passing it Ford Mustang in 1969, so it will set the value of brand to Ford, model to Mustang, and year to 1969. Previously also we created a car class, but we had to set all the properties outside and the code was getting very lengthy. So this constructor method allows you to just set all of these values in one single statement, right? So it is the constructor method's purpose is to set the value of the attributes that are there in your class, right? So like we have brand, model, and year. So constructor method is mostly intended to set the values of your these properties attributes. So is the example clear?
Yeah.
All right, so we'll just copy and paste this, right? And pretty simple output. We were outputting the brand, model, and year of our car object 1 and the brand, model, and year of a car object 2, right? Just like functions, constructors can also be defined outside the class. So they can also be defined outside the class, just like any function. First declare the constructor inside the class. So first you will declare the constructor, you'll give the definition to the constructor inside the class, right? And then define it outside the class by specifying the name of the class followed by the scope resolution operator. So this double colon is called the scope resolution operator. So these double colons are called scope resolution operator, followed by the name of the constructor, which is the same as the class, right? So here, as you can see, like any other method that we like with any other method we were doing, similarly with the constructor we are giving it the definition inside the class. Then we are using the scope resolution operator to define give it the definition. So we're saying brand is equals to X, model equals to Y, and year equals to Z. And this program will just work like the previous one. Alright, so this program will also
Yeah.
run just like the previous one, but one thing to note when creating the constructor outside the class, constructor, when giving the constructor definition outside the class, what you can do, you can name these parameters anything. So like inside you name them string X, string Y, int Z. Outside over here you can give these parameters any name, like string 1, string 2, and integer 3, right? And you can just set the value of 1, brand to 1, uh, model to 2, and uh, year to 3. So you can change the names of these parameters outside. It's not compulsory that the parameter names that you have given inside the when creating the declaration. So you have given X, Y, and Z. It's not compulsory to use the same parameter names. You can use any parameter names you want outside, but you have to have the same amount of parameters, right? So you have to have the same amount of parameters. It's not like you have one less parameter or one more parameter like int 4, right? That won't work.
Okay.
So this was our constructor method, and this was constructors. Now we will move on to access specifiers. So as we saw briefly before, we learned about public, private, and protected. Now we are gonna see this in details. By now you're quite familiar with the public keyword that appears in all of our class examples. So we are giving public continuously in all of the examples, right? So like every time we are giving public. The public keyword is an access specifier. Access specifiers define how the members, attributes, and the methods of a class can be accessed. So when giving public, under public, whatever you give, that will be publicly available from the class, meaning that you will be able to access those properties and methods inside the class and outside the class. Like over here we are saying car object 1 dot brand, car object 1 dot model, car object 1 dot year. Similarly, car object 2 dot brand, car object 2 dot model, car object 2 dot year, right? So we are able to access the attributes outside our class car, right? Because we have given public as the access specifier. So the members are public, which means that they can be accessed and modified from outside the code. However, what if we want members to be private and hidden from the outside world? Right? So if we don't want them to be accessible outside, what we can do? In C++, there are three access specifiers. The public one that we already know, then we have the private one. Members cannot be accessed or viewed from outside the class. So any private basically attribute or method cannot be accessed outside or viewed from outside the class, right? Finally, we have protected, that members cannot be accessed from outside the class. However, they can be accessed in inherited classes. So inherited classes, as I told you in brief, that like if you have your vehicle class, for example, you can also create a class car that will possess the properties and methods of vehicle. So you can inherit a car from vehicle, right? So a car will be a child class of vehicle, right? So you're inheriting all the properties and methods of vehicle. That is called inheritance, right? So if we name our class vehicle, then we can or any other like class, we create any other class. After inheriting, all the protected properties and methods will be accessible inside the inherited class, and also in the class itself. The protected ones do not are not accessible outside, and private are just accessible inside the class where they are declared, and they are not also accessible in the inherited class. So is the public private protected concept clear?
That's clear.
All right. So in the following example, we demonstrate the differences between public and private members. So we have the public member X in this class, and we have the private member Y in this class. Now we are creating an object. We are saying my object dot X is equals to 25. As X is a public attribute, we are able to change it, use it, view it, whatever we want to do, we are able to do with it. But when we say my object dot Y equals to 50, we are not allowed. We are not able to. We are not allowed to assign it any value. We are not able to. We are not allowed to view the value of it, right? Because it's private. We are not allowed to access it outside of the class. So you'll get an error that Y. It will tell you that Y is private. That's why you will get error. Like error int my class Y is private within this context, right?
Yes.
So
Okay.
yeah. So what I what, you can't also, if you try to print the value also, that won't happen. If I try to do C out,
Mhm.
it's saying not allowed, Y is private, right? So you can see the error, it's saying not allowed, Y is private. Now I believe that by default, if you not give public and just directly give variables inside the class, they are by default private. So now if I try to access my object dot X also, then also we'll get an error. So he's saying, it's saying uh, int my class X is private within this context. So you're not it's not necessary to give this private access specifier. By default, if you give no access specifier, by default, without any access specifier, the members are private. So if I give no access specifier, the members are private.
Okay.
So by default, all the members of the class are private. So it is possible to access private members of a class using a public method inside the same class. So there is a way to access private members of a class using a public method inside the same class, that we'll see in encapsulation. This process is called encapsulation, right? So we're gonna see how to access like if you want to create a read only variable, for example, that you can only read and not write to. So then we can create a method inside our class which will allow return the value of a private variable. So it will allow us to read the private variable, but we won't be able to change that variable, right? And similarly, you can also create write only private variables, right? So we'll see that in detail in encapsulation. Right now, we're just gonna see these access specifiers, that by default all the members of a class are private if you don't specify an access specifier. So W3 Schools is also telling us that by default all the members are private. Now encapsulation. So if you wonder, let me just close this. There should be a way to access private members. Like if you want to read the private member only, or you want to write to the private member only, there should be a way. Yes, encapsulation is a way to basically access private members outside of your class. So the meaning of encapsulation is to make sure that sensitive data is hidden from users, right? So sensitive data is hidden from users. Now what do we mean by this? If you have a private variable, if you want just people to know something, right, and not able to change it, right? Some things you want people to know and not be able to change, right? So we want people to know something but not we don't want them to change something. Then we can create a getter. A getter method is called is used to basically access the show the values of our private variables. And a setter is basically allows you to set the value of your private variables. So getters and setters methods, getters allow you to read the value of private variables, and setter methods allow you to write to the value of private methods. So till now, is it clear?
Yeah, it's good.
Alright, so we are also gonna see this in coding, right? So to achieve this, you must declare class variables or attributes as private that cannot be accessed from outside the class. If you want others to read or modify the value of a private member, you can provide public get and set methods, right? So how can we do that? How to access a private member? To access a private attribute, use public get and set methods. So let's see over here. We have an employee class whose private variable is his salary, right? Now in public, we are creating two methods. One is the set salary method and one is the get salary method. The get salary method is a getter that will return the value of salary. So whenever we call get salary, it will give us the value of salary, right? So if it's like 1 lakh over here, it will give us the value 1 lakh. Whenever we call the set salary method, we have to pass it an argument and it will set the value of salary to that. We are gonna see this in action right now. For example, let's have this like this. Alright, so now for example, we'll set the salary to like some number. I don't know, ones, tens, hundreds, thousand, a lakh. So it's 5 lakhs, right? So salary we have set to 5 lakhs, and salary is a private variable. Now what we do, we have a public variable, right? So we are creating public methods, right? Set salary and get salary. As a viewer, as a user of the program, I don't know what this is, as I cannot see the program. So as a user, I can only see the output screen. I cannot see the code, right? So I don't know the salary of the employee. But for example, I want this to want to make this read only, right? For example, I want to make a salary a read only variable that people can only read it but not change my salary. So what I can do, I can say I can create a get salary method, a public get salary method that will return the value of salary. Now if whenever I call, when I create an object, if I directly try to access the value of salary, I'll get an error, right? But if I use this getter to access the value of salary, then I will get the value, right? And because we have only created the getter for the salary variable, I won't be able to change the value of the salary variable. So I cannot say salary, or sorry about that, I can't say my object dot salary is equals to 10 lakhs or whatever this is, right? So this will give us an error, as this variable is read only, and plus I didn't add a semicolon. So let's just rerun this. So this is giving us an error as it is read only because we have created the get salary method. What if I wanted to make it write only? So what I can say, set salary, right? That will take in the value, like for example integer new salary, and we'll say salary is equals to new salary. Now this is write only. If I try to access the value of salary, I won't get it. So it's giving us an error that you cannot read the value of salary. But if I say, for example, my object dot set salary, and then I give it some value like 10 lakhs, right? This will set the value of salary, right? We don't know it, but it will set the value of salary, right? There's no output. So if we just see out inside this set salary method only, like the salary, then we can see that it has changed the value of salary, uh, right? So we are getting some error. So let's just there's a problem with replit over here, so core dumped or something. So we'll just use the other editor of W3 schools that we have. So if I just copy and paste the code over here, so it will set the salary. Oh, there's no return type of this. It should be void over here. right? So this was the error over here. This is a setter first of all, and this should be void over here, right? As it won't return anything. It's not returning anything. So the return type should
Okay.
be void. That was the mistake over here, right? So it set the salary to 10 lakh, and we are printing basically salary to know what the new salary is. So here we once created the get we created salary get only, right? So read only, and now we have created it write only, right? So encapsulation is very powerful. You can create private variables, read only, write only, or both, right? So you can work how you wish, right? So the salary attribute is private, which have restricted access. The public set salary method takes a parameter s and assigns it to salary attribute. So salary equals to s, and public get salary method returns the value of the private salary attribute. Inside main, we create the object of the employee class. Now we can use the set salary method to set the value of the private attribute to like 50,000. Then we call the get salary method on the object to return the value. So this was just the example explained from this text, but the main purpose of getters and setters is to make private variables read only or write only. So why encapsulation? It is considered good practice to declare your attributes as private as often as you can, right? So that other people cannot read your attributes on whenever they wish, right? So encapsulation ensures better control of your data because you or others can change one part of the code without affecting other parts, right? So this you will know the purpose afterwards. It is also increasing the security of your data. Like let's just take a practical example. You shouldn't be able to change the salary of a person yourself, right? The his boss or someone decides the salary of that person. So you can create a getter only to know the salary, but you can't change the salary. So that's where uh, uh, private why you should use the private methods and variables, right? So there are many applications of private methods and variables that we are gonna use them further in this tutorial also, right? So now we are on inheritance. Now the thing we have already been talking about so much, class inheritance. So in C++, it is possible to inherit attributes and methods from one class to another. So is encapsulation clear? I forgot to ask you on that. Hello?
Yeah, it's clear.
Alright. So in C++, it is possible to inherit attributes and methods from one class to another. We group the inheritance concept into two categories. Derived class, that is the child class, the class that inherits from another class. And we have the base class, that is a parent class, the class being inherited from. Right? So inheritance is will allow you to inherit or take the properties of one class in another class. Right? So to inherit from a class, we use the colon symbol. In the example below, the car class is the child and it inherits the attributes and methods from the vehicle class, that is the parent. So we have the vehicle class which has public attributes brand Ford and honk toot toot. Then we are saying class car, and we are inheriting from a vehicle, right? And we have to say public vehicle, right? So this is the syntax. We have to say public vehicle, and we say public string model is equal to Mustang. So we get the properties and methods of the vehicle class inside of this car class. We also can create our own properties and methods. So over here, when we inherit, we get the brand, we get the honk in this class, and we also have model. So in car we have brand, honk, and model. In vehicle we have brand and honk. We don't have the model because model is defined inside the child class, which inherits all the properties and methods of vehicle. So we are inheriting the properties and methods of vehicle inside the car class. So we are getting brand and honk inside the car class, right? And then we are creating our own properties inside the car class, like model, year, etc. So we can say int main, we are creating an object of a car class. We can call the honk method, we can access the brand value, we can also access the model value, right? So we can do multiple things. Let's just try this out. Let's just try it in its editor. All right. So here we have, for example, a vehicle class, right, which has a brand and honk, and we have the car class. So in which we have honk, as we are able to access honk from its object, and we are able to access brand also from the car class's object, and we are able to access the model, right? So is this clear? Hello?
Sorry, I was on mute. I didn't realize.
All right. Is this clear? The concept of
It's clear.
inheritance. And why and when to use inheritance? It is useful for code reusability. If you want to you have two classes, one class has the same properties as the other class, so you can just inherit from one class to another class, so that you don't have to rewrite the attributes and methods of an existing class when you create a new class.
Okay.
All right. So we have multi-level inheritance, so we can do that before the class ends. So a class can also be derived from one class which is already derived from another class. So for example, you have one class which is derived from another class, right? From that class also you can derive another class. So this will be clear over here in the following example, where we have my grandchild that is derived from my child, which is derived from my class. So we have my class which has a my function which will show some content in the parent class. Then we have my child that is inheriting from my class, and it will get the method my function, right? And we are not creating its own methods, right? So it only contains the my function method. Now we can also derive a class from the my child class, right? So we can also inherit from my child that was already inherited from my class. So we can say my grandchild is inheriting from my child, right? And because my child only had my function, then my function will also be only there in my grandchild, and we are saying public my we are not giving any properties and methods of its own in my grandchild also. So all of these three classes will have my function only. So when I create an object of my grandchild and we call my function, so it will just print some content in the parent class, some content in parent class. Now for example, I inherit over here in my child, I say public, say public uh, right? So we say public, and we say uh, int x is equal to 10. So now my child will have the method and x is equal to 10. Now when we inherit from my child, right? So when we inherit from my child, we'll have its x property and also the method that was inherited by it. So it inherited the my function, and which we are further inheriting from my grandchild, right? And we will also inherit the x property as it's a part of our my child. So is multi-level inheritance clear?
Yeah, it's clear.
All right. So next concept, we have multiple inheritance. It's a small concept. We have 1 minute left, so we need not rush this concept. We can do this tomorrow in the next class, right? And you, if you want, I'll just suggest you to do the exercises that are left, right? So you can just directly go in C++ exercises and do the exercises so that your concept is clear. And try to
Okay.
do a recursion code, one more recursion code, right? So that your concept is now more clear, because recursion, as I told you, was a difficult concept. So just um, try to just find a problem statement, and then you can just show me tomorrow the code.
Okay.
All right. So thank you. I hope you like the class.
Thank you so much.